Good morning, good evening, good afternoon, everybody. Hi, Matt. Thank you for joining, everybody. How's it going, Matt? How are you today?
I'm excited. I get to speak 2 hours for 2 hours about my favorite subjects. Yeah.
Yeah, that's good. Thank you all for joining. I see people from Phoenix, from Costa Rica, from New York, Chicago, so all over the place. I guess a couple of people from outside the states as well.
No
So
pressure.
yeah, pardon? Yeah. So it's great to see you all. Thank you for joining. It's part 3 of our Road to Nodes workshop series already. So it's time is ticking, and is the big event is approaching. But a big event being Nodes. So I'd like to remind everybody. Nodes is coming up on the 16th and 17th of November. It's going to be a 24 hours live stream event. So that means wherever you're based, no matter what time zone you're in, it will be something in your daytime live to watch and to exchange ideas, discuss with the community, and see live and have a good time. So I hope you all have registered. If you have registered for a workshop only, you are not automatically enrolled. So you need to register for Nodes as well. Please do so. Link is in chat. And I know you know where to find it, but please do that if you want to take part in Nodes itself. But today we are doing, as I said, part 3 of our workshop series. So it's all about handling Neo4j data with Apache Hop with Matt Casters. I'm pretty excited about this. It should be fun. Before we dive in, chat is open. So if you like to, just say hi or say how cool you think this is or how much fun you have, or if you have a question, obviously use the chat and type it in. There's a Q&A section, so if you have a dedicated question, it's sometimes easier if you use that for questions, so we can easily segment and find out. We have, obviously, I will be in chat and help out with some questions. Then also we have Bart Mertens in chat, who is a friend and colleague of Apache Hop and obviously of Neo4j, I guess. So so it's great to have you here on in chat as well, Bart. He will help out with some questions as well. So it's we should be set. We should be good to go. And yeah, with that, I'll get rid of this and I'll hand it over to you, Matt.
Thank you very much, Alexander. I'm looking forward to this. Maybe we should do a short 5-minute break at the top of the hour. Is that what we typically do?
Yeah, we
Yeah.
can do that. Yeah, we can do a short break. We can do some
If I
questions in there, or we do, just a quick.
if I
Yeah,
for, if I forget, just ping me or something, or just butt in.
yeah, 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 yeah.
All right. Let me just go full screen with the presentation. Um, is that something I need to do, Alexander? Or
At the moment, yes. Here we go. At the moment, you can, if you, yes,
does
perfect.
that work?
That works. Yes.
All
Let me
right,
click
cool.
this. Perfect.
So yeah, so I'm wearing the hoodie. So it's just a little bit about myself, right? I'm the chief solutions architect at Neo4j. It doesn't really mean that much. I'm just helping um, large enterprise and partners think about how we can build solutions with Neo4j in the stack. And obviously, data orchestration is often a big component of that. And so I listed up a couple of topics: an introduction to Apache Hop. So what is it? Why are we building this software? And what can it do for you? And then we go. This is a workshop, right? It's not just a presentation. So we're gonna teach you how to set up Hop from the website. Download it. Make sure that you have an up-to-date Java runtime environment on your system, and then explain a little bit about the basics later on about what are the components of Hop, what can you do with it, and then we'll dive even more deeper into the Neo4j functionality that is available standard in Apache Hop. You don't need to do anything specific for it; it just comes standard with the toolset. And then I listed up a bunch of we call advanced topics, but these are topics where you should run into pretty quickly once you start doing real projects. Like, I want to run something on a Docker container. I want to maybe run something on integration testing, unit testing. How can I set that up, right? And then with a little bit of luck, we'll have a little bit of time over for Q&A and wrap up stuff. All right. So this is the tagline that we came up with as a project. So Apache Hop facilitates all aspects of data and metadata orchestration. And it's sort of like a tradition in the Apache Software Foundation to create these short sentences that don't really mean all that much. So I listed a couple of typical use cases like data integration, data orchestration, ETL, extraction, transformation, and loading, data migration, message processing, data synchronization, IoT, big data sort of operations. But also, data acquisition for AI, ML, machine learning. Yeah, there's so many use cases these days that the list is too long. Why are people typically using ETL tool, data integration, data orchestration tools? And it is to bridge the gap between the needs of the organization and their requirements and the technical side. So what we're doing with these tools is bridging the gap between that tech and the organization. So we're trying to balance the concerns of organizations like setup cost, maintenance cost, running cost, time to market for solutions, resource availability of people, and the bus factor, right? What if my my one developer on let's say Apache Spark that knows all about Kafka all of a sudden leaves the company? It doesn't have to be a fatality, right? You can just leave. The DevOps side, what about that? We want to make sure that everything is managed correctly. Uh, and solution stability, investment protection. We don't want things to uh, turn to chaos. And the needs of the developers' concerns, they want to be able to succeed and have fun and learn new things and work with new technology, that sort of stuff, right? And so Apache Hop aims to lower development and maintenance costs and increase transparency, improve stability of your solution, and make the learning curve steeper. And we are in a quickly diversifying technological landscape. The last attempt at unification of technology was, I think, the Hadoop stack after the mainframe. It was like the new mainframe, right? I'm going to do everything on Hadoop. That didn't really pan out the way that we hoped. So it makes it hard to manage complexity, right? And Neo4j is a guilty party there as well. We propose to put a graph database in your network, right? Another new piece of technology. And we know that from analysis in larger operations, the more systems that you have, the higher the number of permutations of data connections between all those systems. It just increases exponentially with the number of systems. And so we wanted to do a project by and for data orchestration professionals to solve those kind of things. Yeah, so like GNU is not Unix. Hop is the Hop orchestration platform. And with orchestration, we mean like pipelines and workflows. So pipelines, I'll explain a little bit about that later on, or parallel engines that process work in parallel, multiple tasks at the same time, and they send rows of data to each other. Workflows are business process management systems that say I have a starting point and then I evaluate a condition and I go to perform a task, evaluate if it worked correctly, and then I go on to the next thing. Metadata orchestration and management is really important. Pretty quickly in any complicated scenario, you end up with things like connections to your relational database, to your Neo4j database, file locations, file layouts, and so on and so on and so on. So managing that, putting version control on top of that, stuff like that is important. gaining insights. What is going on? What is execution? What is executing? Can we see what's happening in a pipeline or workflow? What happened last night? Uh, who committed something on Friday night, right before they went home and broke the build on Saturday, right? And then configurations, handle ecosystem complexity. How can I create something that runs on my laptop and then later also runs on a Docker container? And so we decided to build a whole platform, not just a graphical user interface, but the whole suite of commands, servers, scripts, Docker containers, API, and so on and so on. And last but not least, the community is the most important thing. The software has been and always is a community-led initiative. And the starting point of that was Kettle version 8.2, some 3-4 years ago already. And a lot of patches and plugins from the community that was collected. It represents, almost 22 years of software development. And it was rewritten from scratch. The GUI was rewritten, the architecture, the metadata backend the tool set was rewritten. It's hardly recognizable if you look at the code now. And it represents years of additional work on top of what was available. The project is a top-level project at the Apache Software Foundation since almost a year, I think. And we just released version 2.1 last week. Grab it while it's hot. And we're already working on 2.2. I'll talk a little bit about what's going to be in 2.2 and how you can help us test that and give it a shot. And our community continues to grow. We have statistics on that. It's like a slow, steady growth every month. We gain follower on all social media. We get more pull requests and stuff like that. So it's a lot of fun. And we do regular Hop Hangouts, and we do number 17 in a couple of weeks. So feel free to join it. Obviously, we carry an Apache public license since we are copyrighted by the code base. The Apache Hop code base is owned by the Apache Software Foundation. That's the point of having a software foundation, right? And so it's the Apache public license for all components, all parts of Apache Hop, which means it's very safe for you to use in any business context. So you can drop it into your own closed source proprietary stack, whatever. It's no problem. You can pretty much do what you want with it. But we hope that you also contribute good ideas back to us. So what is cool about Hop is that it's completely metadata driven. So there's no code generation going on anywhere. So we start from metadata, which is the orchestration metadata is usually like, okay, I need to read a file, and I have a description of that operation in XML or in JSON and metadata. We have a modular pluggable architecture. So despite the fact that the download now is something like 600 plus megabytes, you can scale that still back to something like 30 megabytes, which is important for smaller devices like edge devices, a small Raspberry Pi you have running somewhere. And all it needs to do maybe is send some temperature data to a remote web server or something every hour. In that case, it would be very simple to just deploy a Hop pipeline for that, right? And we have support, embedded support for Apache Spark, Flink, and Google Cloud Platform Dataflow through the Apache Beam project, which we tightly integrate with. Our documentation is completely version control, and the website is then automatically updated. You can find on the website not just the documentation for the stable version, but also for the upcoming version, so that you can see what you can always correspond the documentation with the version of the software that you're using, even if it's like an older version. And so, yeah, we're proud of the fact that we have integration testing running every day for hundreds of components of Apache Hop to test that they remain compatible basically and stable and working. And a little bit about the graphical user interface. It's something that a lot of people will be using daily. So this was written from the ground up to be a scalable interface, and this is especially important for not just the new, let's say, 8K screens or whatever, or these very wide things, high dots per inch, but also for visually impaired people. And if they have special lenses or something to watch a screen and set a really big font on their system, you need to follow, right? The software needs to scale everything accordingly. And so we did that. We're using perspectives for easy, fast context switching between metadata editing and data orchestration work or search or something like that. And we try to design it for not just web browser, but also mobile users with single click mode for faster navigation. And so we run on 4 platforms: Windows, OS X, Linux, and web, which I'll show later on. And we supported dark mode on all platforms, also Windows in the last version, and Hop Web as well. So yeah, so everything that you can configure through the through the GUI, right? You can also configure through command line version, hopconf, which is really important because not everybody is always on the GUI. Sometimes you need to deploy something through 2 layers of SSH tunnels, and then no GUI, no fun, right? So you need to be able to configure and do all these things on these remote servers. And I'll talk a little bit about the central configuration system, which makes it easy to get to configure your environment, the server, the workstation, the user that you're working with. And we have cool things like configuration and metadata inheritance from other projects, which makes it easy to set up things like multi-tenancy and a server where you maybe have 100 projects for 100 different customers. Standard Docker container, like I said, stateless server supporting multi-tenancy, so you can hit that Hop server with multiple people and multiple projects from various sites, and they will not interfere with each other. That's what that means. All right. So yeah, setting up Hop. Let's take a look, right? So Apache Hop, and you can just hit the download button, and there you will find 2.10 in all its glory from last week. And it's a simple zip file. You can just download that. And the only requirement that you have is that you have an up-to-date Java 11 runtime environment. And maybe we can share this slide deck, Alexander, later on or in the chat.
I will share the
deck.
deck.
Link to it, so you should have it.
Yeah.
And so,
can you click on this little hide button on where it says share your screen at the bottom of your?
Sure.
Yeah, cool. I'll share the links and I'll share the slides, obviously. With
everybody. Or a PDF of the slides for people that don't have access to Google Docs. So why is this important to use like a really up-to-date runtime environment? It's not really important for server-side operations, but it is important for front end. So for the GUIs, because on Windows, for example, Windows added a lot of cool new features like improvements for dark modes in their own API, in the Win32 API. And so making sure that your OpenJDK build is up to date is really important. And so the Eclipse Adoptium project intends to do exactly that. But Microsoft also has a build of OpenJDK which is really up to date. And Linux automatically updates sudo apt-get install OpenJDK, whatever, right? And on OS 6, I think the Azure builds. Uh, make sure make sure to use the ARM version of your Java version if you're running on an ARM system. Uh, that makes sense, right? So Apache Hop detects that and picks the right one. All right. So by default, if you start Apache Hop, what we will present you with is a default project and a samples project. But obviously, if you're working in enterprise, you want to create your own projects, you want to do your own thing, right? And that's what we'll do today. We'll configure a folder. Let's just dive straight in, and let's go to Hop. And so what I did here is set up a bunch of variables, the ones that I showed you. So the Hop config folder, what that one does is it points to a folder, and I'm just using the, let's say the Linux.local share paradigm. What that will do is it will create a file here called the Hop config file. And the Hop config file has all the variables. I'm not going to go through all of it. But at the back end, it also contains like all the projects that you set up. It basically is one file that contains the whole shebang, right? So it's very, very easy to do that. The second variable, the Hop audit folder, that one um, contains all the information that you want the GUI to remember. So some stuff like, oh, what is the last files that were open when I started the GUI? What was the last project? Just to make it easy for you to use the GUI. You know, we remember all sorts of things, and yeah, so um, it's just ease of use. The Java Home, so Hop Java Home, this one. So if you have like a system on which you require Java 15 or 17, for example, to run Neo4j, if you don't run Neo4j in a Docker container, but if you run it on a system, it will point to a different Java runtime environment. With Hop Java Home, you can just point it to the Java 11 that you also have on the system. And with Hop options, you can set all sorts of Java environment options. Typically, this is used to set maybe, I don't know, the minimum and maximum amount of memory that you can use in Hop. By default, we consume 2 GB, so that would be minus mx 2G. And on my system, I set it to 8 gigs because I have 64 gigs on my laptop. And finally, if you have databases to connect to, like Oracle or Microsoft SQL Server, you typically don't want to put those drivers in the Hop download binaries. You want to put those in a separate JDBC driver folder so that you can easily upgrade Apache Hop when version 2.2 or 2.3 arrives. You can just replace that with new binaries without having to make any changes to the shared JDBC driver folder. All right, that makes sense. Just to make your life easier. All right. And so let's go over a little bit. What are the tools that we have then in this download, right? And so Hop config. So if we run that, that gives us like a whole plethora of options. It's become quite the beast. Anything from configuring how to access Azure, and this is for the Azure block storage. So the ability to seamlessly read and write files on Azure block storage, or to configure, projects, environments, generated fat jar for Spark Link, that sort of stuff. It's all in HopConf. And This is a pluggable system, so there's a whole bunch of plugins under here. I'll just list this. Um, relational database drivers, engines like all the Beam engines are in there. Technology like Neo4j and AWS and Google are in here under here. All the transform value data types, stuff like that. So anytime that you say I'm going to remove like a folder, subfolder somewhere, it might remove options, right? Because you remove the Azure plugin, and all of a sudden you don't see that option in HopConf anymore. Or vice versa. More interesting, maybe to some of you, if you add a plugin, then you can add more options to this HopConf thing. All right. So Hop Encrypt is to obfuscate or encrypt passwords. Hop GUI, I will show that in a bit. That starts the GUI. I swear it's all pretty intuitive. The only thing we didn't anticipate is that we would have so many commands. So we have this idea of coming up with a hop command and then subcommands, just like you would have with Git and others. Right? Hop imports metadata from our predecessor Kettle, without the integration. Hop run allows you to run a pipeline or a workflow, pretty straightforward. Hop search, allows you to search through a project that you have maybe defined on your system, and it crawls through all the metadata, all the pipelines, workflows, config files, anything that you have for that project or environment, and it will search for keywords. Pretty cool. And Hop server starts a server. It's a small Jetty server. It's not a GUI, but it just waits for work to be sent from other locations. You can also configure it to accept web services. We'll talk about that later. And Hop Translator is a tool that is used by the developers, well, our internationalization contributors, right, or committers, and they are using it to translate Hop into various languages like Chinese, Portuguese, French, Italian. And so if you see Hop GUI pop up in your own language, you have those folks to thank for that. And there's like documentation. If you want to join in on the fun, it's pretty straightforward to use that. Um, all right. So version control. So the Hop GUI. Let's just start it up for a minute, right? So Hop GUI. So pretty pretty straightforward. On Windows, you have the hopgui.bat file, and so for this workshop, I created a project on Git. Just give me a second to find my. So this is like the GitHub repository, but it's linked in the slide. So when Alexander posts the slide somewhere, you'll have the link. But it's on the Neo4j Solutions GitHub, and it contains like this the examples that I'll talk about today. And what you can typically do is just get that code right. Typically, you would do something like let's just go there. I did it in here, Neo4j Solutions. Then you just git clone this thing, and what you end up is a folder called Hop Nodes, which is modified a little bit. I just had to change something, right? And what we can then do in the projects here is add this project. In fact, let me just kill this. Let's just start all over. There you go. So create this project, and then go to that git Neo4j solutions, and this one. And so this new project, what that means is simply like it's like a pointer for the hop configuration to know that this is like a reference folder that we're going to use, right? And so yeah, there's already a configuration file. Let's use this, and let's not do this yet, right? So now that we can go to version control and actually see like, okay, what is the information that I have in Git? I did like an initial version where I checked in all the work. This tree here, these revisions, when it concerns things like, I don't know, a pipeline, uh, you will if you have like multiple revisions, you should be able to see a visual diff as well. And then if you click on that, it will open up the two revisions. I will not go too much into detail because, yeah, the first half hour is already gone. We can't divert too far from the pad. Um, but in any case, so if you do have changes, um, you can just use git add and commit and push and pull to keep that git repository up to date, which is your project. Or you can use a command line, or you can use your favorite Git tool. But yeah, so what we think is important is for you to do check in all your work, all your pipelines, workflows, everything into version control. All right, let's go back to my slides. So yeah, so here's the link to that GitHub repository. And so yeah, a project encapsulates everything in a single folder and also makes it easy to specify any files that you load, maybe reference files in a relative way, right? Dollar project home. And this is important because on your system it's located on maybe in your home folder somewhere. On a server it's located in a different path. But if it's all relative versus the project reference folder, you don't need to worry about it. It makes deployment and lifecycle management in general a lot easier. So that's the project that we created. And so the project, if you want to manage that across like multiple environments, and let's do this for my local development. Um, let's go to the create an environment and call this local development. And the purpose of this is just, development. I think, where did I put it? So here did I put this? So this is like a JSON file. Let me just show you what's in there. So what did I put in there for my local environment? I put the host name of my Neo4j server, with which I'm going to do all sorts of demonstrations, right? And obviously, I'll also be switching over to an Aura variant of this, and so I can create another environment maybe, which I will call Aura dev, right? So and I will select the same one for Aura. And in here, I'm pointing to my Aura password, which is fine because I'll delete the database after the workshop. And you can obfuscate these things as well. And so now I can easily switch between the various environments, right? So def and yeah, let's follow the script a little bit. So let's go through the basics a little bit, right? We do have quite a bit of documentation on the Hop website. So if you go to this link, the concepts, Let's go there. You will get the same explanation. What are the tools? What are the various big components like pipelines, parallel engines, which process buckets of information, and workflows, which are like sequential in nature. Let's take a look at a workflow, and I'm following. So I found like an older data set that's documented on the Neo4j website, the Northwind example, which is quite simple, right? It's uh, customers and products and orders and suppliers. And so this is a typical example of a workflow where I'm doing things in sequence and there's a clear starting point. And so what this thing does is it pings the Neo4j server. How does that look? I can just click on the name of this action, what we call, right? This icon, there's a name underneath. I can click on this and see like, oh, this is pinging my host name, in this case, the Aura server. And if that works, I'm going to see if this server is up and running. It's not just going to try to connect, but it's going to do, I think it does like a match or just return one or something. It gets something from the database to say, hey, I'm up and running. And if that is okay, then it's going to make sure that there is a bunch of constraints defined for this model. So unique constraints on the nodes that we're populating. And what will happen with these things is that if you're deploying something on a server now, and for some reason in some complicated Docker Compose or Kubernetes system, you can't even ping the server or you can't even connect to the Neo4j server, then you don't have to start creating constraints, right? And then you can clearly say, oh, it failed straight up here. I don't need to look in my log. I don't need to go like 1,000 log lines deeper because I know this is what we call a defensive setup in ETL and data orchestration, um, where we test assumptions. So I can assert in a Java program. And so then we end up with the first pipeline, right? And this pipeline is has like an icon with like three waves. It's like parallel things happening, I guess. And if you click on any of these icons, you get a lot of actions. And one of them is open the pipeline. There are other shortcuts to do that. This is a very simple example of a pipeline where we're reading a text file with delimiters. This is just the natural stuff, right? And these two icons represent transforms, which will run in parallel. And they will feed data one to the other using the arrows, which we call a hop. uh, and so if you run that using the local engine, it will basically load data into Aura. This is a very small data set, but it shows you two transforms running in parallel. There are various ways to make this different and faster and whatever, but that's the way it goes. So this is all running, and we can make this run against Aura, and so this is a pipeline, right? On the left, you can see like a bunch of icons which represent the perspectives. So this is the data orchestration perspective in which we're doing all sorts of development work, right? So we develop the workflows, the pipeline, and right beneath that you have the execution information. And I'll talk a little bit more about that, but this basically um, explains how something was executed and captures information, sends it off to a location. In this case, it's a Neo4j database that contains all this information that you're seeing. We'll explore that a little bit later. Beneath that, there's like a perspective for all the metadata. And the metadata contains things like the Neo4j connection. We already saw a few things about that, Um, um, I'll go in depth in how this is configured to be as environment resilient as possible. But yeah, the typical things is that you try not to hard code anything. If you have a need to configure the database name as well for this specific connection, you can use an environment variable here as well. Every field in the Hop ecosystem that has like a dollar sign to the right, in these text fields you can enter a variable, and this is pretty much everywhere I think these days. um, and you can use something like you don't have to type this manually. You just control space and then Neo4j, and yeah, that's pretty much how that goes. um, okay, so this metadata, just to quickly notice, is stored in a subfolder of the metadata folder. And so this is stored as a simple JSON. If you really need to change something, you can also use your text editor, or indeed the next tab, the next perspective, the file explorer, which I already showed. The file explorer is pretty primitive in its editing capabilities, but it allows you to do a lot of stuff. Um, And the next perspective is search. So this works with something like we call like search locations. In this case, I want to search the whole project. Let's say Neo4j host name, right? Since we use this case sensitive, and so it finds this used in a few cases. So this is the ping and the Neo4j connection itself, but also as a variable in the config file, and so you can click on this and just go straight to that. Right? So this is pretty cool. And yeah, there's also a perspective which shows you all the plugins that are loaded in the environment. You'll probably not use that a lot. This is more for the developers, I guess, than for anybody else. But it's pretty cool to see. And finally, there's a new for J logging or auditing perspective, which will probably become obsolete pretty quickly because most of the functionality will drop into the execution information um, perspective, right? But then again, it's the same functionality whereby setting an environment variable pointing to your logging connection, all the execution information, well, not as much, but a lot of information gets sent to Neo4j, giving you the execution lineage, basically. All right. So that's like in a few words, a lot of information. Um, I'll leave it to Bart to pick up the slack there. So yeah, workflows and pipelines. So different animals, different use cases, actions, and so workflows have actions, and transforms have pipelines have transforms. We use that terminology to be the same as pipelines and transforms is being used in Apache Beam. So that there's no confusion there, we make sure that everything is the same. All right. With that basic introduction out of the way, maybe open it up for a few questions before we start diving into the Neo4j stuff. What do you think, guys?
Yeah, we can. I mean, there were a couple. Bart was active
All right.
in answering those, but we can maybe do one or two in on the stream as well. So one question was on in relationship to Kafka
Mm-hmm.
and how they can be used alongside one another. Is there something you could
Yeah, yeah. So
explain?
I will do a demo later on using Kinesis, an example of Amazon Kinesis. I guess Kafka is similar in that nature, right?
Mhm.
I think I have an example here where this is using the Apache Beam Kinesis Consume transform. But I guess if you have like the Beam Kafka Consume, it's pretty much the same, right? So you can configure all sorts of things like the Bootstrap server. This is running in a Beam context. There's also another Kafka, which is the older one, the Kafka consumer, which guards transactionality, like the ability to only acknowledge read successfully processed messages after they're successfully processed in a batch, maybe by using a sub pipeline. That's for using the classical, the older engine. So yeah, a lot of options for Kafka, including support for Avro schema. Um, yeah, it's pretty advanced.
Cool.
I
A
think
couple of
yeah.
people had high praise for Hop. So here I see
No.
one says fantastic product as interface to all data sources. And another comment was multi-environment support on Hop is a fantastic feature, makes moving between dev, QA,
Yeah,
and prod a breeze.
yeah. This is important, right? Um, so I think it's underestimated. So if you work for large environment, for large companies, you always often see that, okay, so it took 3 months to develop something, and then another 3 months to put something in production. This is not something that is acceptable in any shape or form. It should just take 5 minutes to put something in production. It should be the time to create a new environment file, type in the names, usernames, passwords, server names of the of the production systems, and that should be it. Right? And you should have tested that in a test system already, where that or even on a Docker container. And we use
Yep.
this infrastructure ourselves in the Hub project to do integration testing, but I'll talk a little bit about that later if I have time. All right,
Yep.
cool, great questions. So yeah, really a lot of data sources. Uh, it would just. I have here a Snowflake connection uh, to to test with. Maybe I'll run this, but here's an idea of all the different databases that we support, and even so, we had Brandon on the chat on the community side chat saying like, yeah, I found an issue with Dremio. They have their own driver, and okay, so I guess we'll have another connection pretty soon, right? And there's more and more Apache projects like Derby, Doris, Hive. There's what was that one? Um, yeah, Iceberg. There's a lot of them that are just coming up, and we'll just keep adding those all relational databases. And in a lot of cases, if you're populating your Neo4j graph database, you prefer not to read from a text file or you want to go straight to the source, right? And that's perfectly possible with Apache Hop. All right. The Neo4j functionality, um, just uh, the Neo4j connection. Um, so Neo4j is like an older project, right? And so we are dragging along a lot of functionality. And to Neo4j's credit, they're making things better and better. Um, but to support a lot of use cases, um, we split this up into basic, right? So the basics are the connection is configured automatically. You put in your host name, port, 7687, username and password, and it just works. You hit the test button here at the bottom, and it works, right? And then for those special cases where things are not configurable automatically, and this was the case for us for Aura for all sorts of reasons, because it's using a self-signed certificate or whatever. Um, you can configure these checkboxes with variables as well, in the sense that I can just show you, right? Um, so automatically configured as yes, then it will just do this. And in the case for Aura, like I just showed you, you have a bunch of extra options. So, but yeah, in most cases, it's just pretty straightforward to configure that. And there is documentation on the website as well for the specific cases that you want to do. All right. There is like a cool webpage on the Neo4j website. So if you start with the default setup, you have a samples project, which will contain a bunch of examples, right? Um, you need to do a setup of this. And like I just said, it requires these 4 environment variables to be set. You can do this with an environment file, create somewhere, and then it will work, right? And it makes it easy. Suppose that you have like Neo4j desktop on your system, and you create a new database in there on another port. You have a whole bunch of them. You can just create environments for those things. Just play around with those. You have environment files for every single database that you create with Neo4j desktop. That's a great way of doing things as well, right? There's a bunch of cool examples which go along the lines of what I'm showing today. But I thought it was cool to create a new example, which was this one. Um, so what are we doing with load category? Uh, yeah, reading from a file. Let me just run this again. Um, if you run something, you see this like a little grid here. If you click on it, you can actually see the data that is passing through it. These are the last rows that passed through or exited were output by this transform. So it's in reverse order, right? Um, because in most cases, when something goes wrong, and something always goes wrong, you want to look at the last row that passed through a transform, not the first one. So let's take a look at the Neo4j output. The Neo4j output, incidentally, was the first step or transform that was ever committed or ever contributed to the ecosystem. Actually done by Bart Martins, who is now busy answering questions. So thanks, Bart, for contributing this at the very beginning. Obviously, in the meantime, in the years that went by, a lot of options were added in the sense that it's quite a capable beast, um, and all its simplicity, it allows you to address 2 nodes, like a from node, a to node, and then the relationship between those two. And so if you look at this thing, and we just want to create categories, and there's no 2 node relationship, we can just leave that empty. And um, in this case, we set a static label value category, or you can add multiples. The cool thing with this transform is you can also set like a field in the input that will contain the label for the node. Now, this is not something that is supported by the Cipher standard. And so we do this by generating the Cipher statement for the user. So there's no technical knowledge that is required here. The cool thing is that it's very easy to just use these buttons, get fields, and say, okay, this is the primary key because I need some primary key. Unless I do create, I need a primary key to have a successful merge operation on the node. All right, so that's pretty much all there is to know about that. It works really well, and it will always try to do things in the fastest way possible for you. So in this case, it will use unwind statements in the back to make things as fast as possible, right? So so that's pretty cool. I think that is also using the Neo4j output. And as you can see, the more of these fields you have, the more benefit you have from using these GUIs, because typing in these cipher statements with all these set let's say C dot customer ID equals dollar customer ID, something like that. It gets tedious pretty quickly, and again, it's harder to maintain these things. Right? What it also will do, and this is shown in the GUI, but I just mentioned it, um, is automatically do data type conversion. So if you need to convert from a string to a number or an integer or something like that, then Hop will try to do that for you so that the database doesn't have a problem with it. The Neo4j cipher transform is the powerhouse, right? You all know I love cipher. Cipher statements can be used to read or write, and so read from graph database. Typically, we use the read only statement checkbox here to signify Neo4j to Neo4j, especially for clustered applications. This is important. Um, if you run in a clustered environment and you have a read only statement, that means that in a lot of cases, it can address any of the nodes, any of the node replicas, and as such, improve performance. That's if you maybe have a data orchestration, a pipeline that bombards Neo4j with all sorts of shortest path statements for a whole range of products. Maybe you can do cool exercises with that. All right. The first tab is just which connection, what's the batch size. You can even do retry on error. So if you have locking issues and do things in parallel, and you can retry. The parameters, again, you can just hit the get parameters button and it will repopulate this thing. Like you see, it will do things like properly change the case and change it to an acceptable parameter name. So remove spaces and do stuff for you automatically for you. Again, just save time and typing. And then you can type in whatever kind of merge statement you can come up with. I am actually doing something weird here in the sense that this is an unwind statement. This rows command comes from here, from the rows option. And so now I can address row everywhere as a parameter, I guess, so that we can support unwind statements. So it's merging products, setting these things, and then also creating a relationship with the category and with the supplier, right? Incidentally, whether or not it's a read only or a write read write operation, you can always return values as well. If you would put like a return, let's say product, hang on, Matt, product ID as PID or something. I can just return that here as PID, probably like an integer, and just go from there, right? Um, in this case, I don't have that. So this is how the cipher command works. I just this is part of the samples, but if you want to do like parallel inserts into parallel create statements, you can always click on the transform and specify a number of copies. Like for example, I want to do this in two different threads or five different threads or whatever. You can do that. Um, all right, so that's a cool one. I think the orders for this one, I did something different. We have like I don't know if you're familiar with the new data importer. It's like um, a web-based, graph model-based type of loading. We have this in Hop as well, and so we built a small like graph model here for Northwind. Anyway, so you can define the nodes and the relationships here, and in a very simple user interface, and it's capable of importing information from arrows.app, for example, or from our Neo4j solutions workbench, which is used by our partners mostly. Makes it easier to edit. But after that, you can just say, okay, input field this is going to this order ID property. Since this order ID property is properly marked as a primary key, it knows that, oh, I need to do a merge statement. It generates the whole merge statement for you. And it has like advanced features, which I'm not demoing today because I don't want you all to zone out too much. But it has things like node label mappings where you can say uh, for the mapping on a specific target name, I'm going to use a field value from a certain field, input field, and if it's if the value is L1, I'm going to use label 1, which is then matched to the model. The pretty advanced use cases that came up out of the field, out of the services people that we have. Same for relationships management, which relationships, all relationships that are defined in the graph model or just specific ones. Anyway, so this is useful. Somebody mentioned Kafka. In a lot of cases, you're getting like a JSON file, and it's not just one node or relationship that you need to manage. You need to manage like a whole bunch of them, right? Uh, you need to update something for the customer, something in an order, something here, something there, and then it becomes tedious pretty quickly to write these cipher commands or or use Neo4j output a whole bunch of transforms, and this takes the sting out of that, and it takes care of the fact that maybe there's like a null value for a primary key, which automatically excludes the node from the generation of the cipher statement. And by allowing out of order updates, it can also use unwind statements. In that 1,000 row batch, it will just sort the statements by the cipher statement that got generated, and you never end up with very small batches that way. There are not that many permutations in practice. All right. Um, So those are the three main transforms. I think I already shown you how to check, how to create constraints. There's another action here, which is called Neo4j index, which is similar to the constraints in the sense that you can create or drop an index on like a node customer, and maybe you have like an index customer ID, and there you go. Now I have like an index that gets automatically validated in my workflow before I do the heavy lifting work. Um, so that's like a Neo4j index. Incidentally, these things you don't have to type this in manually if you have like a graph model like Northwind. You can just click this button, copy Neo4j index constraint to the clipboard for this connection, all right? And then it gets just pasted in here. That's how I did that. The index doesn't really have anything, but this is pre-populated. This is how we try to save you time and effort. In the next iteration, maybe we could just use that model to automatically just have an action to automatically update all the indexes and constraints for them all. All right, let's go back to the slide deck for a bit. We've passed the hour. Should we do like a 5-minute break after this?
We can, yeah. I mean, up to you. We can maybe do a quick question on the Neo4j
Sure.
integration, which came up from chat from Paul. He
Mhm.
used to use the old Neo4j cipher step coming from Kettle, so a long time user,
Oh yeah.
and wrote the cipher code himself. What's the difference between this old step, if you're still using it, or in the new graph output feature, or is there
Yeah,
performance differences?
we fixed a lot of bugs, and I think the performance has improved 1,000-fold or something.
Okay.
by switching to a proper unwind statements and optimizing a lot of code. Yeah, it's in certain scenarios it's a lot faster. Yeah, it's yeah. What we're also trying to do every release, there's a couple of cases that we fix where we say like it's not like there's a bug in this transform, but we try to give more information about, hey, dear user, you're asking me to do a merge on a node, but you didn't provide a primary key for. I don't have a key to merge on, so this is going to fail regardless. And then now in 2.1, we say like, hey, let me just do an error message somewhere. Otherwise, you're going to end up with the wrong data in your graph anyway. So
Oh, yeah.
that's sort of continuous improvement that we do using the feedback from the whole community, right? And you know, we would love for anybody that's listening to be part of that, like, part of that life cycle, right? Part of that feedback loop. It makes everything so much better. Yeah. Great question. Yeah.
Absolutely.
All right.
Yeah, I mean, if we
Yeah, let me just grab some water
yeah
and just
just
give me a
do a short
minute.
break, and we'll be back in a second.
Yeah, 5 minutes.
Yeah.
All right. Sounds good.
Cool. I'll stay around. So if you have any questions, anything else you'd like to discuss, we can talk about this. Other than that, yeah, everybody take a few seconds to break. Grab some water yourself, or other needs. So we we come back in a few minutes. But yeah, I think it's interesting, very cool, and very fun. And I can obviously take the time and repeat again, register for notes. So yeah, I'll pop the link into chat again. It's gonna be good fun, and I hope to see you there in November. So it will be really good. With that, Matt is back, so let me be back. Yeah.
Yeah, I just wanted to grab some ice water.
Yeah. Lots of talking.
Yeah. Yeah, we can continue. You know,
Yep.
I'm good for it.
Let's
I
continue.
think that we should take like another half hour and maybe stop 10 minutes early or something.
Mhm.
If there are more questions or people want to dive into other topics that I haven't covered by then.
Yeah, absolutely.
Yeah. So we kind of like went over this Northwind example. Like again, you know, you can follow the link. You can just grab that project from GitHub, and you can zoom around there. All you need to do to get it working is create your own environment file, put in a couple of variables, and then you're good to go. Yeah. So for Aura, that's exactly the same, right? So if we go to Aura and take a look at match C category. There are only like 9 categories. These are the things that they populated earlier when we ran. And it's pretty simple stuff. It's it's easy to switch. It's easy to do this, and it's easy to create more projects. Just to clarify that, because we only have one project here, right? So suppose that we go to the parking and create a new nodes tests folder. Nodes test folder. There you go. We have a new project. Um, it will ask you to create like new um, uh, workflow configurations or pipeline configurations. I haven't really talked about that, but a pipeline configuration basically defines how you want to run your pipeline, whether or not you want to use the standard local hop pipeline, or maybe you want to run something, use something else like the Beam engine, like say a local. And for the workflow, it's the same. But we could also say like, oh, I have like, I want to execute this thing remotely, like on a Hop server. Like, I'm not gonna. So we can define a Hop server. I don't have one yet, so you can create a new Hop server that we have running, maybe in a Docker container. Uh, so this is how that tags together, and I'll show you an example later on for Dataflow. So this is how that works, and maybe we can create like a simple pipeline here. Generate rows, generate like a million rows, and it's best practice to give the name of the transform, make it meaningful, make that name meaningful, right? Uh, the dummy is always like a dummy. It's always great to do nothing. Output maybe. So let's generate rows. This is how easy it is to create these pipelines, right? You just, if you know what you want to do, and if you just look for CSV or read from a database table input, or you can just do that and then run, and then you can see that that million rows is done. If you then switch to the other project, it remembered the last open file, and this is what I said earlier about this Hop audit folder. This is where that one becomes important. Not only does it remember the file, it remembers the zoom size that you used, stuff like that. It makes it easy to stay in the context that you were in, and then I guess you just move back and forth, right? Great. So uh, what else did I want to show? So for Aura, go to Aura. You can run this. Very easy to switch around. Let's take a look at that. So yeah, so everything that you need as far as extra environment variables, you can just set those in here, and they get picked up. Um, they will not bleed over into other environments and stuff like that. So it's safe to do that. Let's go back here. Um, then obviously, Aura is a very nice solution, right? It's a fully managed database. Um, you can just create a new one in 5 minutes. I have a small one running here, a 16 gigs version with 2 CPUs and 8 gigs of RAM. You can do a lot with that already, and it's not that expensive. And so what we'll try to do now is do something else, right? Because if you have like a fully managed Aura database in the cloud, um, and you have something like a BigQuery database where a lot of information is, and it's also completely in the cloud, or the example that I have here, which was Snowflake. So So Snowflake to Neo4j, I found that there was some issue with dates. There's always an issue with dates, with time zones. Anyway, so um, I'll talk a little bit more about batching and optimizations in a Spark, Flink, and Dataflow context, but we need to do a little bit clever batching. Anyway, so if we run this on we call Dataflow, we're going to ask um, the Google Cloud Platform to start a new job, what they call it, a new pipeline, and it's using the Hop fat jar. And I can point you to the documentation. It's very easy to generate this from the user interface, generate fat jar, or using a command line tool. I'm going to run it on in Europe West because that's where I am, and this is where my Aura database is running. I can use a worker machine. There's like a lot of types. The four then designates four different cores that it has, which is plenty to keep the database busy, I guess, right? And in the logging, we can see that it started this pipeline, and so if we then go to the jobs here, I already tested this earlier. The data flow, um, the data flow system is quite cool in the sense that you don't want to manage your own Spark or Flink cluster, right? If you have a fully managed Aura database, that I don't have to care about that. That runs fine. I don't have to care about Snowflake. I don't want to start up. I don't want to manage my own Spark cluster, right, or Flink cluster, or anything. I just want to use something automatic. And what this does, Dataflow, is start its own cluster, right? It starts up one worker node. I asked it just to use one worker node with 4 cores on their own Kubernetes environment, but I don't need to know anything about this. So this is what that thing does. And the only thing that's weird about this is that it forces a single thread for that first transform, the customer transform, because it's a non-beam transform. So make sure that only gets executed once. And so it started one worker, and slowly it will start to ramp up. It's not meant for small jobs like this with only like 1 million records, but it gives you an idea of what's going on, right? It means that we can run this pipeline that we designed in a lot of different scenarios, in a lot of different engines, a lot of contexts. And what that means is that you can decide what the optimal architecture is for your data orchestration work. It's not Hop that is enforcing anything on your behalf, right? All right, cool. So this makes it easy to load data straight from wherever data source that you have, including the Kafka use case. In the case of that Kafka use case, what we will see is that you have like a never-ending pipeline. In the Beam terminology, is called an unbounded pipeline, never-ending. And yeah, so Apache Beam will take care of transactional consistency and everything for you by squeezing the data through the pipeline in bundles. Yeah, all right. I have another example here for BigQuery, which is yeah pretty much the same, right? Here it's doing a little bit of init capping on the state by saying the state field just use like a lowercase and then do init capping on it, which makes it a little bit easier on the eyes. Coming from yeah, there's a select star from this nodes database that I had as a test, and again, that's how easy that is. Uh, Incidentally, if you have this running, you will get some metrics. Um, it will say the number of times it initialized this particular transform. This is a very small engine and a very small use case. The data flow engine is has an algorithm to automatically scale. So if it sees a benefit in adding more transform copies, then it will do that. I think the data volume is a little bit too low to really let it go berserker, but yeah, it was just to give you an idea of what's going on. All right. Uh, I see that's already 20 past. Let's go back to the presentation. Bulk loading. Um, I'm not going to spend too much time on that because I want to keep like 15 minutes for other topics. Um, but I just wanted to show you a couple of cool possibilities. So for bulk loading, that's Neo4j admin, right? Uh, so Neo4j admin import needs CSV files to do bulk loads. Now we've had like cases where one of my colleagues loaded a file and he was cursing and he said like, yeah, it was loading fine until row 67 million, and then there was like an invalid escape character or an invalid UTF-8 character or whatever, right? Because yeah, you don't always have control over the data that you get sent. So this one, so generate CSV, um, this allows you to generate files that come from a graph field. Now, uh, let me just take customers here as an example. Let's take this. So suppose that you have like this customer's example. We can opt not to write to a database and say, instead, we're going to write to a graph output field, which encapsulates the information that we put in here in the GUI in a small graph field. The way that that looks, uh, generate CSV sample. Right? The way that that works is if you run this, the local agent, you will see that there is like a graph output field, and that graph output field basically is represented as JSON, but it can be picked up in by this Neo4j generate CSVs, because now we know that this graph field contains the information for this particular node, and yeah, we can give this a customer's prefix, and for smaller data sets, you can say, for uniqueness, I want you to compress this down to a unique set of values. Typically, this is not a good idea. I would advise you to do something like a sort and unique. So sort the rows. Where's the sort? Sort rows, for example, um, by customer ID, and only pass unique rows, right? To get a unique set of values, you need to do an external sort. This is an external sort, so that it will never run out of memory. It will just stream to disks and then merge the assorted smaller data files. All right, so that's a better option. At that point, you can read like a billion rows here and get a consistent set of CSV, one or more set of CSV files. Because if that can take some time, you can say I'm gonna run this in 4 different copies, right? Or there are various strategies to make that fast. But yeah, then you can say uh, customers.csv, right? That's what you generate. And the output, interestingly, of this transform is a file name and a file type, and you can save those into a temporary file maybe somewhere. And the next transform you can then use once you generated all the files that you want to bulk load is the Neo4j import command, which uses those file name fields and types and fields. because writing the Neo4j admin import command is, yeah, it's sometimes a work of art, right? It can be like if you have a lot of files, and it's great to have a lot of files because then you can manage them more easily. You can parallelize things more easily. Yeah, it becomes like a task just to write the import command. This does that for you, so it will just take as input all the fields, and the field type is then know the relationship, and the field file name field is then the file names, and it will just generate that command for you and run that automatically for you. And having those in the toolbox means that um, you can do automated Neo4j admin exercises from within Apache Hop. All right, I just wanted to drop that in. It will lead us too far to cover all the angles here, but yeah, the Neo4j admin import wants the data in the CSV files to be as clean as possible. It will not do any. Will prefer not to do any additional work, and that's what you want, right? You want this thing to run as fast as possible without having to worry about extra checking off of file types or layouts or whatever. Right? It just needs to be clean and properly done. And these two transforms will help you with that. Cool. All right. So a little bit about yeah, jumping all over the place about Beam versus Neo4j best practices. Um, so if you, well, this is not just for Beam, but this is uh, for that instance, like that small instance with two cores. If you are loading data in there, make sure that the parallelism matches the number of CPUs a little bit. You know, in Dataflow you can pick the right type of worker, but on Apache Spark and Flink, you can set the parallelism in the run configuration. Let me just quickly show this here. Uh, I've added a couple of examples. Um, so there are ways to define like the default parallelism. In Flink, it's like in here, but there's also like a way to do it on the server. In Spark, I think it's a little bit trickier. But yeah, so in general, I think for node creation and merges, I think it's fine to do a lot in parallel. Neo4j will handle that quite nicely. It's more of the relationships that you can worry about. I already covered Beam Batch. It's documented on the website, of course. Um, but yeah, setting a flush interval and buffer size in the run configuration kind of helps you not just in these streaming exercises, but also in these large volume data transfer, where you don't want to have small batches coming into Neo4j. Neo4j is just a clustered database, and it's just not comfortable with that. It prefers like 1,000 rows at a time, and um, especially in the streaming world, Flink, Spark, streaming, Dataflow, they try to chop everything up in very, very small batches of one or two records. And that might be great if you want to have really low latency, but it will hurt performance a little bit. So then you can tweak that with the flush interval. Say it's fine to keep it around for half a second, right? Or a second. It's not that critical, or even 5 seconds. It's fine, right? So that's something you can define on that level. All right, now to the fun stuff. Maybe ask if there are any questions about this thing. I know that I went through it pretty quickly, but it's, I think, pretty self-explanatory. And there are examples and documentation.
There were a couple of questions, but
Sure.
not. I don't think necessarily to this. I mean, you explained the beam part, so there was a question on that.
Mhm.
So I think you understand it. An interesting question that more of a general question, I think, is can you, when you set up your pipeline, do
Yeah.
you have the possibilities to see if it all works without committing committing data, basically?
So what we have for that is a system of unit testing. I think we used to have a slightly different name, but for example, you can set up a unit test for this thing where well, let's call it like not a unit test but just a testing, right? This is for development purposes. It's not for unit testing purposes. Um, so now this is activated, and now actually we can say like, um, for this test case that I'm doing, I can just remove this from the test, and it's like a cross, right? So this is not going to get executed now if I run this
Hmm.
with a local engine. So there's only like these two. Uh, there's a lot of other cool stuff that you can do. Instead of reading from this file, I can actually read I can specify an alternative input data set, or I can specify an alternative output data set. And why are we doing that? Because yeah, sometimes you need to connect to some Hive database on an old Hadoop system, and running every query takes you an hour. It's just tedious, right? So you run it once with an hour, and you capture maybe a couple of thousand records, and you put them in a new data set. And this new data set can be defined here in the metadata, or automatically create data set using this file specification, for example. And so again, there are cool articles written about the way that that can help you develop stuff. At some point, what you're doing is almost like test-driven development, right? So if you have
Mhm.
input data set, you can hand this over to somebody and say, this is the output that we require. Now write the pipeline in between. And in those scenarios, even though there's like a Neo4j output transform in the mix, nothing will be written to the output transform. It will be replaced by a dummy at runtime. If we do golden data testing on it, we will just compare it to the golden data at that point.
Okay.
Does that make sense?
Yeah, I think that
All
makes
right,
sense.
cool. Great question.
Yeah. Yeah, I think,
All right, cool.
yeah, let's continue.
Let's plow forward. So execution information is a cool new option in version 2.1. And so what we're doing here is saying like every time that we execute something like this thing, we update a graph, right? And in the case of this, it allows you to see not just when you're running in the GUI, but even if it's running off of a Apache Airflow scheduling, or Docker container in Kubernetes, in the cloud, locally, remotely. If you can connect to uh, that location, that execution information location, which is defined in the metadata. Let's take a look. So the execution information is either local here. I have one that's local, which is just pointing to a temp folder here. But obviously, since this is a Neo4j session, in this case, the Neo4j database is in Aura. And so now we can go to Aura and see how that looks like. And I have here like a really cool query. This is calculating the shortest path for all the execution nodes that get populated automatically by Hop in that database. And it finds like the root, which is where parent ID is null, and a child where parent ID is not null, and it finds like the shortest path. And what that will give us is basically all the paths that were taken from this pipeline, this workflow, sorry. And it's pretty cool because you can see the XML for the workflow that got executed. It tries to save the whole state of everything that goes on, and you can see that actually it didn't really. It probably slows down a little bit, but you only notice it because it's like a small. These are like small pieces of work, and So that's pretty cool. So that means that you can just follow exactly what was executed, how, when, and where, and which variables were set at that given time. Not only that, if you take a look at something like that and go to, for example, customers, just to take that example again, and go into that, you can drill down into that pipeline, and you can actually click on this transform and then see data sets accompanied with a data profile that you created. And this data profile basically is just defined as the last 100 rows, right? But there's also the option to say the first row, 100 random rows from this pipeline, or even do data profiling exercises like calculate minima, maxima, and stuff like that for all transforms, which will slow down your large pipe, your voluminous pipelines a little bit more. But in any case, so you can set up this data profile and then specify to use that in your pipeline run configuration. Means like now that we're running, I want to send this data off to the graph database or to a local, and I want to, for all the transforms in this pipeline, I want to do a little bit of data. I want to capture data from the last rows, right? Um, but yeah, so there are there's documentation about this, and there's some cool new improvements coming in 2.2 as well. So pretty cool stuff that we're using, like the graph database. The next thing that we're going to do for 2.2, and I'm going to talk about, is allow our plugin system to add like specific Neo4j tabs here, which we use the shortest path query to say like, oh, I have this transform, and maybe there was an error, maybe it errored out. How did it get here? Show me the whole execution path all the way to the root of this, right? What's the path that got taken? What were the environments? What were the last rows before it failed, right? That's what you want to know as an ETL developer, as a data orchestration developer. And that's where Neo4j is really great at figuring out the paths and traversing the graph that is that execution graph. Right, cool. I see that I'm babbling too much. So this is how that works, right? So the execution information gets sent off to either a Neo4j database or a file, or to an Apache Hop server, which delegates it then to a Hop. Unit testing, I already covered that a little bit. Interesting to note is that we have a whole suite of integration tests that we run every night, and sometimes they fail if we're doing development. But yeah, so this is pretty cool. I think it's actually failing because of Neo4j 5, right? But let's skip that for a second. So for Neo4j, we run like a whole suite of integration tests, which test all the various scenarios for example, the Neo4j graph output, Neo4j output, Cipher, returning special things, all these edge cases, see that we're not leaking any connections, right? We envision like a test for that. So that's what we're doing, and we're using Docker Compose on the Apache Software Foundation Jenkins servers. It's a pretty cool setup that we have. So we can test, for example, Apache Hop with Neo4j. We can test Apache Hop with MongoDB. We can test it with Postgres. We test all these combinations and run a whole suite of tests. But the cool thing is, this is all open source, and you can do the same for your project. So if you have a complicated pipeline that you want to test, the way that these things work is we start with a clean Neo4j database, wipe everything in there in the Docker container, and then write data to it, and then read it back out and see if it matches golden data with the unit test that I showed you earlier. And that works really well. It catches like everything that moves or fails, like Cassandra 4 upgrade failed, and now we're seeing something with a with the latest build of Neo4j 5 development, I guess, that we're using. Pretty cool that we know before we're going to do the next release that we need to fix that, right? All right. What else? So yeah, logging and reflection. If that's not enough, you can create your own pipelines to log everything that the pipeline does, all the pipelines and workflows do to, for example, AWS S3, stuff like that, right? Um, Incidentally, I touched upon this very briefly, but um, Apache Hop supports like a virtual file system driver, which makes it possible to connect to AWS, Google Storage, or Azure Blob Store natively from the GUI. So I can, for example, take a look at an input file on Google Storage without having to go to the Google Storage website. So it will switch directly uh, to the Explorer perspective, and I can even edit this file. Right? So web services. So you can create synchronous or asynchronous web services which execute a pipeline and give back the result as from a field, the content of a field, as like say a JSON file as a result of that web service. It's pretty cool. You can do the same for a whole workflow. So you can do like orchestrate like a whole bunch of work on a Hop server automatically. Trying to stick to that 15-minute margin that I gave myself, but hey, there's so much to talk about. So a lot of people want to use Docker containers. It's pretty straightforward to do that. There's like a cool documentation about using Hop, the official Apache/Hop container for short-lived or long-lived setup. And a long-lived setup is a Hop server which runs in your network. Suppose that you have your own application and you define a web service on that Hop server, and you want to hit it, then you can use that. And short-lived is it runs a workflow or a pipeline and then shuts down again, which is great as well, right? For these cloud-based setups. Hop Web is also pretty cool. So you can run the whole GUI in a browser. Let's see. I had like here it is. So this is going to run like the latest development version. We have a bunch of tags like 2.1 latest or 2.2.0/snapshot. But since I'm feeling adventurous, I'm going to use the development snapshot. And what this does is it starts a Tomcat, and so then you can use your browser to navigate to that. And this will show you basically the new welcome screen that we're working on, and it will show you the samples project. And in here you can then open, like, for example, one of the Beam examples. This one, the complex one, shows you all the various possibilities like merge joining, stream lookups, which is like a side load in the Beam context, filters sending data to different directions, the switch case, if you have like these fan out things. And then you can just run this with, for example, Flink, which is the streaming runner, and it will do that, right? So without any pain, you can basically you can just experience a little bit. So we're continuously improving this. This is not the end of the road. We're working on making this even easier to set up. And with that welcome screen, we will certainly be capable of of directing people to the examples and make it easier to run stuff and find the examples. So that's where we're heading. So that executed, right? So yeah, so that's that. You can also customize Hop Web because it's a Tomcat. You can change a lot. There's like a developer's guide for that. Here's like an example of how to use the bash operator to execute this thing in Airflow. Obviously, you can also use the Docker operator in Airflow to do that. Uh, yeah, and on Kubernetes, I had this really cool example of how to run a pipeline on AWS, the Elastic Kubernetes service of using the Apache Flink Kubernetes operator, but we'll postpone that for another time. This is documented on the Hop website, so you can follow the link. It's pretty straightforward. You can set up, you can create your pipeline and then deploy it using the Flink deployment, which is a Kubernetes operator of the Flink project, and it does pretty much what Dataflow does, but on AWS. And it runs at the back. You can set up your job. It runs your Beam pipeline with the metadata on a newly instantiated Flink cluster that gets automatically started up on Kubernetes, and it's just one command: kubectl create, and it starts to do all these things for you, and it runs, and you can monitor this. Uh, you can do a port forward and see what's going on. If there's any interest, I can show it later, right? All right. A little bit about the roadmap, and then that's the end. Then we can do a little bit more questions. So improvements and bug fixes, those are really important to us. There's like always people improving things, fixing bugs in the UI, and we get more and more of these contributions coming in. These are really important because there's nothing worse than just downloading the next edition of a piece of software, the next version, and seeing that the same bug that you had last time is still in there. Why not just let us know about it? Create a bug in Jira, and on the Hop website there are links to all the ways that you can do that in a free way. We'll expand the integration test suite if we have a chance to do that. If we do find a bug and fix a bug, we make sure it stays fixed. Well, like I said, we're working on a new welcome dialog with direct links and guided actions. And a new configuration perspective is also in the works to make all the configurable options of the Hop environment, like, I don't know, keys for Azure, the one that I talked about a few hours ago, and have all those in one place. Like give plugins access to the execution information GUI, like the Neo4j tab with paths to errors. That's also something I will. I'm also working on a new Neo4j cipher builder transform, which I guess I can show you quickly. I still have a minute, right? And so the cipher builder transform basically allows you to create a whole bunch of operations like match, merge, create, delete, and so forth and so on. And it will then show you the cipher that it uses for that. So it's built like a cipher builder and a cipher learner at the same time. And for those operations that are, like I said, there are certain cases where you want to do these weird things, and I think it's useful to have like an environment to do that, which also offers like helper buttons to populate these dialogues to work faster and to have validation, all sorts of validations. Yeah, so we want to do quicker releases. 2.1 was a little bit long on the tooth in the sense that the vacation period was in there, and there were like a couple of big ticket items in there. So I think we plan to do a 2.2 earlier in a couple of weeks. So yeah, with 9 minutes to spare, thank you very much for attending. Please join our community. You are very welcome to join. Here are the links to everything. And now let's see if we have any more questions, Alexander.
Super cool. Thank you very much,
Yeah.
Matt. You got a couple of very nice comments for how you presented this and how you showed us through this. So I can only repeat that. Really good presentation.
Thank you
Very
very much, guys. Appreciate it. Yeah.
good demo. I had one that also comes from chat is about the transforms. I think they seem pretty cool and what you can do with the data there and how you can manipulate
Yeah.
some of the data you're working with. So I don't know. Can you show a little bit more what's possible there with the
Yeah.
transform?
So in general, what we see is that this case here, where you have a category and you load it into Neo4j, that's like the load CSV case, right? It's not a really realistic case. In general, what we see is that there's like I don't know. Typically, there is dirt in the data, right? There's like this is really clean, right? But
Yes.
suppose that you want to replace all the slashes with commas, right?
Mhm.
So yeah, before you know it, you're saying like, yeah, maybe like a string operation. That's just like okay. So let's add a string operation, right? Let's just do this one. I think it was the category name, and remove special characters is a typical one. Like I showed you the uppercase, lowercase.
Yeah.
Another one would be string replace. Uh, replace in string. There's like a replacement of null values, right? If a field is null, what do you want to do? Keep it null or say something like unknown? Uh,
Okay. Yeah.
if a certain field is like if it says like null, maybe you want to just make it null, empty, right?
Mm.
Another one that's used even for so a value mapper, for example. I don't think that I have like an example here, but um, it's very simple, right? So suppose that you have like a measurement. I think we had this case where we did like oil drilling measurements, and the
Mhm.
performance problem was there's like a measurement in a node somewhere, and people were hitting that value, and Neo4j was forced to search indexes for categories of values because you only want to use like high values, like out of bound values. So what you can say is 0 to 10. Um, that's not the one that I want. That's the range, number range, right? So you would say like 0 to 5 is less than 5 is low,
Mhm.
medium, and then high, right? And you make your categories, and instead of like you can put that value in a node property, but what if you would like create a relationship with another node and where you just have low, medium, high, and what Neo4j can then do is traverse these links, these relationships, which go infinitely faster. You know that, right?
Yes.
And so there's like a whole plethora of things, all the way down to really running like JavaScript, like whole scripts using the input values that you have, um, or even Java, or even write your own plugin that can do stuff like that. So just
That is
click on the
wow.
background,
Yeah.
and then you
Pretty good.
see like a plethora of operations. And we know that it becomes somewhat daunting. So we're trying to add more and more keywords. So JSON, it shows up JSON, or string. You get all the string operations, right? Fuzzy
Mm.
matching, like the weirdest things first, right? So split fields to rows. There's another one, split fields. Yeah, and
Yeah.
we did I think a great job and at least having documentation pages for all transforms out there. And again, so if you go to the samples project and open this transforms folder, there's like a stream lookup. How can I side load? How can I load data in memory? I don't know what the flashing is about, but how can I do that, right? How can I, those are the sorts of examples that we will find useful. Right? All right, another question maybe.
That's very powerful and very cool. One more question comes here at the end of your pipeline. When your pipeline completes, do you get a report of what has been processed? How many, let's say, how
Mhm.
many nodes have been written in Neo4j, or how many lines have been processed, or some kind of a summary of
So
statement of
yes,
yeah.
absolutely. So uh, you know, so if you look at something like this, um, so obviously you do have like logging that goes on, right?
Mhm.
Yeah, this is not what I wanted. This is since it's running on Dataflow, I guess. Let's take the local engine. So you have like the logging, which gives you some information. You also have the metrics, and the cool thing is that um, you can get actually access to this if you set up like a execution information location. And if you want to get a hold of this in a uh, let's say systematic way, if you really want to get a hold of the data, there is a new execution information. Um,
Mhm.
Hang on, execution information transform, which can give you things like from the graph database, get the execution IDs. But yeah, you can get a lot of state and information. You can actually query that database using this transform.
Okay.
And in a workflow, um, it's actually shown here. If you click on it, you can see the results. Was this? You can go in a very fine grained. You can look at this in a very fine grained way, and there's even like a JavaScript action. If you look up at the documentation for this, it gives you access to a lot of the information, like how you can evaluate the number of lines. Because sometimes you say like I have a 800 lines of input, and I only write 600. Maybe that ratio is not enough. I filtered out too much bad data, right?
Mhm.
So you could do a lot of stuff with that. Right? Okay. Any other question? I hope that kind
Cool.
of answered it. But yeah, there's a lot of information available. I would start at the high level, just see if it works, yes or no. And then if you find like a use case from a data governance standpoint, that would be awesome. Then you can put that in there with all sorts of methods.
Yeah, I
Yeah,
think
very cool.
that's what we had. So yeah, I mean, you said it here. Let's repeat it again. If you want to know more, if you want to be part of the Hop community, go to hop.apache.org,
Yeah,
join the chat server. You know, be part of the community, and you know, talk
yeah,
to the team. Let them know what you need, what you want. Um,
yeah. We have a dedicated Neo4j channel. So if people come to us with, hey, I'm trying to do X, Y, or Z, it's not always simple, right? People underestimate that when you build a graph, you're pushing a lot of the workloads to the ETL because we're loading uh, nodes and relationships at the same time. Where in a relational database, you just load flat tables,
mhm,
and the relationships are expressed at query time. Whereas in Neo4j world, the relationships are expressed at load time, and Cipher explores the graphs. Right. So there's a difference there, a fundamental difference, which puts more stress on the data loading side, on the data integration side.
Oh, yeah.
And so if we can help with any of that, we're always interested in hearing your use cases, your struggles, because that allows us to improve. And yeah, we keep pushing forward. All right.
Yeah, cool.
Yeah.
Again, thank you very much, Matt, for
Well,
for
thank
the
you.
demo, for the showcase and the presentation of this workshop. Thank you, Bart, obviously, for helping out with all the questions and all the the answers, obviously, for the questions during the session. Thank you all for watching, for participating, for
Yes.
making this interactive and lively as well. I hope you had a good time. We will be back, or at least I will be back tomorrow with another notes training, road to notes workshop. Tomorrow we're gonna do something a little bit different. So we will do blazing fast graphs hands-on with Apache Arrow and Neo4j, so another Apache project. So this will take place tomorrow, more in the graph data science world. I think it's where it's at. So I'm looking forward to that same time as today. So if you like, please register for this. Also, again, don't forget to register for notes. And yeah, with that, thank you all for being here today, and see you soon next time.
Bye.
Bye.